Okay, everybody, here we are. And sadly, if it's not one thing, it's two things, as my old boss used to say. This thing isn't working. Computer's working now, this thing isn't working. It's gonna be something, right? It's always gonna be something. So what does it mean? It means we go back to writing things by hand like losers. Losers. Well, not you guys, mostly just me. But we have one option, which might be helpful, which is we can have our equations up here on the other slide. Way down at the end. Okay. And here's where we are. So this, thank God, is intended to be the last day of Fisher-Gray. We will move on to other things. We'll move on to international economics in particular, in case you're wondering. But we got one more thing to learn, and we're doing this complicated, unpleasant Mankey model that we hate. I don't know about you. I'm assuming you hate it. Maybe you love it. I don't know. But this particular version of the model, where we have, if you look at the equation at the top, we've got these forward-looking, the theta 2, pt plus 1 given t. This is investment, right? This is they're looking forward. If prices are going to go up, they would like to invest now. If prices are going to go down, they would like to not invest now, right? Or maybe it could be consumption as well, a similar sort of thing. Now that added a lot of mess, right? And we found R1 and R2 for our guess, and we know how these things work, so that's where we're at. Okay, that's where we're at. And in particular, look at this. This one here. I need to fix that. It should not be pt plus 1 given t. It should be pt plus 1 given t minus pt, that whole theta 2 term on the top. So this one at the bottom right, which I can't point to because technology, that one, the left-hand side should be pt plus 1 given t minus pt itself is that. So that's where we are. And now we're wondering, can we affect output? Okay. Now I will say to you that you will not be asked to do anything as algebraically miserable as this one. And the reason for that is not that you can't. Like it's the same thing, but more, like way more, right? It means though for like a homework or an exam question, it becomes, did you make an algebra error rather than did you understand what you're doing? And we're really looking for, do you understand what you're doing, not do you make a sign error or something, right? It's not a math class. You need math, but it's not a math class. We're not looking for, now obviously it's better if you do all your algebra correctly, but if you give enough algebra to anyone in a stressful, time-limited environment, they're going to make a mistake somewhere along the line, and that is not useful in a test environment. It's not useful as a thing to stress about in your life either. But I do want to show you this because it gives us a new story, right? And you can see the messiness. And that messiness is one of the things that we're going to learn out of this. That our nice, simple, clean model, you might not believe it, but it was simple and clean and nice, is now all of a sudden manky and unpleasant when we've added this term. And that mankiness and unpleasantness is going to have an economic interpretation, which we're going to come back to in a little bit. Okay, so it's not, the math is actually telling us that there's some messiness going on, and we'll be able to see that in a minute. Okay, so what we want to do is we want to find what yt minus y bar is, given this. And can we see stuff over on the left-hand side? We can. Okay, that's one plus of this technology. We can have them side by side. Glorious, glorious. That's beautiful. Okay, so we just need to plug these things in to our little equation there. Yeah, good luck with that. Let's do it. Let's do it. So, what is, if I can find a pen, always nicer. 2 pens of different colors, ever so slightly different colors. So what do we get? We get yt minus y bar. And I'm going to do everything in terms of r to begin with, because once we bring in what r's are, life is hard, right? So let's do everything just in terms of r at the beginning. So yt minus y bar is going to be equal to theta 1 times whatever this over here, pt minus pt given t minus 1 is, which we know that's going to be r1 times et. Right? And then it's going to be plus, let me put this in parentheses so it makes it a little clearer. Parentheses times pt plus 1 given t minus pt, which is that whole thing down on the sort of right-hand corner, lower right-hand corner. So that's going to be what? R2 minus R1 ET minus R2 ET minus 1. So there you go. Okay. So that's what it is. And we have what R1 and R2 is. So we just plug all those things in and let the glorious happenings happening. Let me put all the ET terms together, all the ET minus 1 terms together. So in particular, we've got an ET term here. We got an ET term there. So yt minus y bar is equal to theta 1 R1 ET plus theta 2 R2 minus theta 1 R1, all that times ET. That's combining all the ET terms and multiplying this bit out. And then it's going to be minus R2 theta 2 ET minus 1. Right, those ET terms, those ET minus 1 terms, we put them all together. And now we can, if we're so inclined and masochistic, we can write what those are. This is probably easier to write this way. Do I have a minus problem? No, it should be okay. Yeah, I'm wondering, do I have a problem? Theta 1, R1. Do I have minus? This should be theta 2, R1, because it's coming from here, right? Theta 2, R2. All right, that looks right. Right? Does it match? Yeah, there. Now it's matching. So we get theta 1 minus theta 2, R1, plus theta 2, R2, epsilon t minus R2, theta 2, epsilon t minus 1. You can see there's loads of places to go wrong in algebra, right? Loads. But there we go. We got the thing. Okay. Now I'm just going to plug in what R1 and R2 is, and I'm not going to do a whole lot of simplifying because life is hard enough. Right? It's truly hard enough. But if we were like really doing this and we were writing a paper with it, we were really analyzing it, we'd simplify it this way, we'd simplify it that way and see what interpretations we can get. But we're just going to put down what R1 and R2 are in here. So I get yt minus y bar is equal to a whole bunch of stuff times et. So we're going to have theta 1 minus theta 2 times R1, and R1 is a whole unpleasant thing, which is, see if I have it, do I have it written down there? Yeah, well, let's see if I write it down the same way, that would be nice. 1 minus theta 2 minus theta 2 plus theta 2 gamma, lots of different ways to write this, of course, over 1 minus theta 2, 1 plus theta 1 minus theta 2. all that times ET minus theta 2 times R2, which is just going to be plus theta 2 gamma over 1 minus theta 2 epsilon t minus 1. Right? Yeah. There we go. So we've solved it. Now, we could simplify, we could screw around with it to our heart's content. Yeah. R2 is over here. In the first, yes, you are so right. You are so right. Plus theta 2 and R2 is minus gamma over 1 minus theta 2. All of that goes in there as well. Absolutely, thank you. Okay. Simple, we're not going to do it. We're not going to do it. But what are we looking for? We are looking to see whether the policy variable has any effect on output. Well, we can see it all over the place, right? We got policy variable is gamma. There it is. There it is. There it is. It's all over this unpleasant thing, right? So, monetary policy is going to affect output. And it's going to affect output through epsilon t. It's also going to affect output through epsilon t minus 1. And remember, in this model, if we hadn't had that theta 2 bit, the part with the forward-looking investment stuff, if we just had yt minus y bar is theta 1 times the price prediction error, right, the standard wage thing, there would be no effect of policy on output, right, because the central bank doesn't have any superior information to people when they're setting their wages. So the central bank will be able to affect prices by increasing the money supply, but it will not be able to affect output because no one's going to be surprised by their behavior because they're using the same information that everyone had when they set their wages. But now that we have this second term in the yt minus y bar equation, now that we have that, now we have investment being forward-looking or consumption being forward-looking, all of a sudden we can affect output, and in like a really complicated, messy, unpleasant kind of way. Like it's not straightforward the way it has been up till now. It's showing up here, it's showing up there, all of a sudden ET matters, all of a sudden ET minus 1 matters. Neither one of these mattered before, now they both matter. What the heck? Right? No? Like what? It's not the same as what we had before. It is a new reason why policy can affect output that we didn't have without this term. Okay, what do I want to talk about this? So, we can do a couple of thought experiments. So this is our conclusion, but let's think of examples. Okay, so these are just thought experiments. This is the conclusion, this is the solution, but we want to understand it as best we can without spending the rest of our life trying to simplify it in 5 different ways. But we can think about some extreme cases, and this is the usual thing in economics, right? We have this equation, this is the general thing, but let's think about some extreme cases and see if we can learn anything from them. So one extreme case we could have is if theta 2 was equal to 0, right? Is the investors just aren't important, right? That's the model we had before, but we can see that what we get yt minus y bar is equal to what? Well, if theta 2 is equal to 0, we get theta 1 times, this is all 1 minus theta 2 over 1 plus theta 1 et. Right, that's just setting in here all the theta 2's equal to 0. And then plus 0 et minus 1. Gamma is not there. So if that second term in our assumed equation was 0, then policy would have no effect on output. It's just what we had before, but it's seeing that, look, this is really coming from this theta 2, this fact that investment affects output. Another thought experiment we could do, if we can get everything in, problematic. Let's make this page 1. Let's get this at the top, like so. Page 2. And our next example, we'll have theta 2's not equal to 0. So we're in the general case again. But gamma is equal to 0. Then what do we get? We get yt minus y bar is equal to theta 1 minus theta 2 times 1 minus theta 2 over 1 minus theta 2, 1 plus theta 1 minus theta 2, all times ET. Okay. So here we have no policy response at all. Or we just let that monetary policy be totally passive. ET minus 1 doesn't affect output at all. Yesterday's shock does not affect output. Okay? Yesterday's shock affecting output is coming only because we have a policy that we're doing. We have this active monetary policy. Okay? And on this, we say, well, today's shock is going to affect output in a complicated, unpleasant way, but it's going to affect output. And why does it affect output? Just to get an idea. Well, if we have a shock today, that means today's prices are high, right? We have a shock today, we have high prices. That means that our expected future increase in prices is small, right? If, like, on the right-hand side, very top left-hand corner, if the PT goes up, this PT plus 1 given T minus PT, that goes down, right? And so if I have a shock through this theta 2 term, that's going to decrease output. Okay. But if I have a shock today, that's going to affect prices. It's going to affect today's prices through the wages as well. Right? So the whole thing is unpleasant and messy, but importantly, when gamma is 0, when policy is not active at all, we just say we leave the money supply the same. This is a complicated model. I don't want to mess with it. Life is hard. Let's just don't screw anything up. Keep money supply the same. Then today's shock is going to affect output, complicated, unpleasant way. Yesterday's shock won't, and there we are. But when we start playing around with gamma, we have gamma that's different from 0. Then all of a sudden, yesterday's shock starts to matter, and it can affect tomorrow's shock, right? So one thing we could do, if we wanted to, is we could set gamma to totally get rid of this shock, right? So another example. Of the ET shock. We could do that. Just saying, well, okay, what gamma makes this thing equal to 0? That would be 1 minus theta 2 plus theta 2 gamma equal to 0. Right? If we could do that, then this whole, well, we also have this one over here. I know it's more complicated than that. Let me not do the math for it. I forgot about this term. Yeah, it's messy enough that we don't want to do it. It's a distraction. But we could pick a theta 2, we could pick a gamma, so that whole thing is reasonably close to 0. Can we get 0? Probably we can get 0. Yeah, we can get 0. Pick it so that it's equal to 0, and then that's lovely. We have no shock. We've totally stabilized the contemporaneous shock, but we're obviously going to screw up the shock from before. So if we're passive in our money supply, yesterday's shock won't matter, but today's shock will. if we're really active in our money supply, right, to get rid of today's shock, we're going to destabilize things in terms of yesterday's shock. So we have a trade-off between the two. We cannot fully stabilize output because it's affected by yesterday's shock and today's shock. And we have to balance those two things out to stabilize it as much as reasonably possible. Okay. So, why? What's going on here? So let's look, there's a slide and everything. And maybe, just maybe, I can point at this thing. Okay. Can it work? Yeah, sort of pointing. Not quite. Okay, well, we'll point as well as we can. Right. So what do we got? Let's get this. That's why. So even with rational expectations and no superior information, we are able to can affect output, right? And why is this happening? It's not because, like if we do nothing, then the current shock affects output. We can change that, and we're doing that not because our money supply is really going to, our money supply is based on yesterday's information, right? Yeah, ET minus 1. But that means tomorrow's money supply is going to be based on today's information, right? So all of this term up here, all of that term at the top, this one here, right? All of that ET term is coming because we're making promises. Right? We're making promises that in the future we're going to increase the money supply. People see today's shock, they see it's high, and we promise them that we are going to increase tomorrow's money supply based on today's shock. So now they know, they see today's shock is high, they know that we're going to increase money supply tomorrow, and they can build it in. So we're making promises to them about how our money supply is going to behave, and so then if we're increasing the money supply, that means prices are going to go up tomorrow, which means it's worth investing now. So that promise that prices are going to go up can cause people to invest now. Okay, so they see the current conditions, they see the ET shock. We can't do anything about that, but we can say, based on today's shock, tomorrow I will increase the money supply. And so they'll say, tomorrow prices are going to be high, therefore I should invest now. Okay? So it's these promises of future policy action that are getting money supply to affect output. Not the action itself, but the future action, the promises of the future action. However, we have this thing, I can't point here, life is so hard. We can't point over here, I can point like physically, like the old-fashioned way. Oh, life is good. Okay. Over here, we have, let me get rid of this. We have this thing, right? If we start making those promises, that is set gamma different from 0, if we start doing that, we're destabilizing output today, right? Because we're trading these off. And that's because when tomorrow comes, like think, we made this promise, I'm going to increase the money supply. I did that so that people would invest now. Okay? Yay, they invested now. Then I get to tomorrow, well, maybe I want to increase the money supply, maybe I don't. But if I'm going to keep my promise, which the model assumes, then I'm going to be increasing the money supply then whether I want to or not. And that's why we get this destabilizing bit here. As we try to stabilize this, we destabilize that because, yes, we can get people to do things by making promises to them, but we're not always going to want to keep those promises. And our promises are based on yesterday's shocks, and getting people to do things are based on, well, we're going to do things based on today's shock, right? So this bit here is keeping our old promises. And this bit here is the effect we can get by making promises. Okay, so And this is so we get this tension between these two things. We try to keep our old promises. We're going to destabilize things, but making promises can get people to do stuff today. Okay. And this, turns out, is a general problem in macroeconomics. And this problem is called time inconsistency. It's not just actually a problem in macroeconomics, it's a problem in life. The way it was explained to me was by my old professor. Well, he was old, probably my age, and also he was a former professor, right? Way back in the day, he's trying to explain time inconsistency, and he has this problem that his daughter just got into Stanford University. Now, we were going to San Francisco State, so we had no sympathy for that poxy daughter. But anyway, she got into Stanford, and good for her. Anyway, and so he's kind of bragging about his daughter, but he has this problem. Stanford's very, very expensive. Right? And so what he wants is he wants his daughter to work in the summer to help pay a little tiny bit of that, at least to show like some kind of gratitude for the sacrifice. Anyway, so this is what he wants. And so he says to her, I will pay for you to go to Stanford if you work during the summer. Right? Perfectly reasonable. And then, of course, what does she do? She doesn't work during the summer. She goofs off. She has a good time. Like loads of I don't know what she did. She's doing whatever she's doing. She's living her life, but she's not working. And what does he do? He pays for Stanford because, like, first of all, that was a very small amount. And secondly, you're not going to give up your daughter's chance of going to Stanford just because she's an idiot for one summer. Right? It's fine. And so this is a time inconsistency problem. Right? The idea is if you can make a believable promise, then you can influence people's behavior, right? If I promise you 10 million euros next year, that's going to, and you believe me, like fool you, but like if you believe that I'm going to give you 10 million euros next year, that's going to change your behavior today, right? And so if I can make a believable promise, that will change your behavior. And here, our believable promise was, next term, I'm going to increase the money supply or decrease the money supply. And if you buy that I'm making this promise and you think I am going to increase the money supply, that means prices are going to go up and you're going to invest. If you believe that I'm going to give you 10 million euros next year, you're going to go on a big vacation and you're not going to work and all that stuff, right? If I tell you, so if it's a believable promise, it's going to influence your current actions. Of course, Dan Wenzel, my old professor, his problem was his daughter didn't believe him. Because it's kind of a promise, it's kind of a threat. You know, it's a threat to say if I don't work, you're not going to send me to Stanford. Well, it's a lie. Everyone knows it's a lie. And so it didn't affect her behavior. Poor Dan. Right. So if we can make a believable promise, it can influence people's actions. However, when it comes time to fulfill, even if fulfill is spelled incorrectly, if it comes time to fulfill the promise, it can sometimes not be a good idea to do so. Like you might not want to, right? And that's what we're getting over here, right? This promise of gamma, that the promise that we're going to base tomorrow's money supply, and therefore tomorrow's prices on today's shock, that can get people to invest or cut back on investment, depending on whether we want to get investment higher or lower, right? But we get this. It ends up destabilizing the promises. These are the promises that we're trying to keep from last time, right? And so there's the trade-off between the two. And of course, in my professor's problem, it was not optimal to follow through on his promise. Not optimal. Well, clearly, you know, if she did it, it would have been fine. But the fact that she didn't do the work meant that it wasn't optimal to fulfill that promise. And so then we have this whole problem about how believable are promises. And we know that expectations are crucial, central to macroeconomics, right? Investment, consumption, all depend on people's expectations of the future, people's wage contracts, short-term contracts for other inputs. All of these things depends on people's expectations of the future, and all of it can have major effects on output. In fact, probably the biggest, most influential thing about where do business cycles come from is based on expectations, right? And so we need to deal with expectations, and then we need to say, well, what are people's expectations of policy? Because we think policy can affect output, and people's expectations are important. They need to form expectations not only of the world, but also about what we're going to do, right? And that involves two components. It involves what we're actually going to do, and how well they can predict what we're going to do, and are we going to follow through on that, right? And here in this model, we've always had promises being entirely believable, right? We say, this is the rule, we're going to follow this rule, and we're assuming that throughout, okay? But in fact, now we see that there are times when maybe it wouldn't be. What we would like to do is we would like to say, tomorrow's money supply is going to depend on today's shock. And we would also at the same time like to say, forget about yesterday's shock, we're going to ignore that. Right? We're not going to, but if we do that, if we ignore yesterday's shock, then they won't believe our promises for tomorrow's shock. And so the believability of these things is a real problem. And this also is a problem not getting me in the shot. So this is why we've been doing rational expectations, right? It says that we have to sort of have a rule, and because we need to have a systematic way about saying how do they predict policy. Well, they must base it on our actions in some way. But of course, in real life, it's messier than that. Now, because of these things, right, it's always tempting to say, well, like there's a lot of good reason why policymakers should lie to people. Like suppose we're in a recession, right, and things are bad. Well, what we want to say, regardless of what we actually think, is tomorrow everything is going to be great, so start spending now. Right? Because if they start spending now, that's going to take us out of the recession. Right? Same thing when we say tomorrow we're going to increase the money supply. That's great. We've made the promise. If people buy it, if they believe what we say, that can affect output now, right? But if we're in the habit of saying everything's going to be great tomorrow, even when we know for sure that it's not going to be, well, people are going to think we're liars, and they just will ignore everything we say. So there's this trade-off between sort of a one-time benefit of doing something versus creating a reputation for being believable. Right? And these days, the trend in macroeconomics, and certainly in monetary policy, fiscal policy involves politicians more, so it's less clear, but in monetary policy is to try to get a reputation for being believable. And there's a number of reasons for this. One, their policy can have these effects. Right? Now we can stabilize these shocks. We can play around with investment because people believe us when we say we're going to do something. And so that's helpful. And also there's this trouble, like if they don't know what we're going to do, like if we have a reputation for lying or, shading the truth or just not being clear, then people are still going to have expectations of our behavior. Like it's not like we can stop them from trying to figure out what we're doing. They're going to do that, right? But then if we're not believable or we don't communicate with people, then they can make up any old thing in their head that they want, right? Because they have to figure out what policymakers are going to do. Well, they could do this. Who knows what they're going to do? We can come up with any goofy thing. And that itself can destabilize the economy, right? We all think just some guy wrote on a blog somewhere, money supply is going down. They're going to raise the interest rates. And we all think, recession is coming. And then all of a sudden we stop spending, and indeed recession comes. Okay? And if they come out and they say, no, we're not going to do that, if they have a reputation for not being trustworthy, for saying all kinds of goofy stuff, then we're going to ignore them and we're going to go into recession. Right? Because if they're not being consistent, if they're not being forthright with what they're doing, we can have any expectations of what they're doing whatsoever, and that itself can destabilize the economy. Right? So we say, this before when we started with the Keynesian model, we said, look, if I think there's going to be a recession next year, I think I might lose my job, I'm going to stop spending. And that expectation can cause a recession in and of itself. Okay? That's still possible. We can't solve that problem entirely. But now there's a whole other reason. I might take, I think, everything's going to be fine next year, except I think the central bank's going to be a goofball and it's going to increase interest rates. Okay? And now I have a whole other reason to send the economy into a tailspin. And so the trend in policymakers these days, for the last 20 years or so, maybe 25, 30 years, for a while, like it's been growing and it's becoming stronger, is to say we have to communicate clearly with people what we're doing in kind of this is our general approach to what we're doing. This is what we intend to do. This is what we intend to do in 3 months. So you'll see statements of the sort like, the central bank is raising the interest rates by 2 basis points, and we are intending, if things continue on, to raise it a further 3 basis points in 6 months. Okay? We're going to raise the interest rate now, and we're going to raise the interest rate again in 6 months. They're trying to communicate a promise so that we take behavioral action now. And for the central bank, this is particularly important because without believable promises, it takes ages for their actions actually to have an effect, right? We could say, okay, the central bank, say, wants to raise the interest rate, right? And so it has to cut back on the money supply, right? So what do they need? To cut back on the money supply, they need to sell something. They're selling government bonds. They're taking in the money. They're burning it. And then, through the miracle of the money multiplier, that has a much bigger effect, right? And so they can change the money supply by quite a lot, and that can affect interest rates. However, we say, yeah, it's done, except it's not really. That whole process takes forever, right? So what do? They sell these government bonds, they burn the money. Now, banks find themselves in a shortfall. They don't have enough reserves because all that money went out to buy these government bonds. So now they have to raise reserves. How do they do that? Well, when people pay back their loans, they just keep the money and they don't loan it out again, right? And then there's less money in the money supply, and it goes through multiple rounds of this. But all of that takes time. It's not like they instantly readjusted the reserves, right? It takes time for people to pay back their loans. That's going to affect the next round of loans. That's going to affect the amount of money people have. Right now, we cut back on our loans. That means that people don't have money that they otherwise would, and therefore, et cetera, et cetera. There's a whole multiple rounds of this thing. All of that takes time, right? And so in practice, if sort of the principles version of how money supply works, if that was all that was going on, the monetary policy would be really, really slow. Right? Not maybe as slow as fiscal policy. I made a big song and dance last year about how slow fiscal policy was, but pretty slow just the same, right? Because this money multiplier would take ages to happen because it involves banking and multiple rounds of borrowing and lending, right? And each round is going to take time. There's actually somebody who has to borrow the money. They have to be evaluated. They need their credit score. They need to fill out a form. And that multiple round is going to take ages, right? And so you could think, okay, we're going to change the money supply. But that changing the money supply is going to take 6 months, a year to actually happen in full. Okay, a large chunk of it would happen in 6 months. But that 6 months where the interest rates didn't change because we didn't really fully change the money supply, therefore investment didn't really change, and therefore output wasn't affected, right? And the investment itself is going to take time. And so all of that means that we're going to be very slow. Okay? But if we can make believable promises, and people believe these promises, but if we've developed a reputation for trust, that when we say we're going to do things, if nothing comes up in the meantime, we actually do those things, then we can go out on the steps and say, we intend to raise interest rates by 2%. Oh my God, that's huge. Everyone going, they're going to raise interest rates by 2%. And then, all of a sudden, we haven't done anything yet, and this whole money supply thing is going to take a while. But people realize, if they believe us, that we are going to raise interest rates by 2%. And in fact, interest rates will go up pretty dramatically right away. Okay? So if we're believable, if they know what we're doing and they trust that what we're doing, we can make these statements, and that will affect interest rates right away. And therefore, we can have an immediate effect on things, or a much quicker effect on things. Okay? And so these days, they go to great lengths to be believable. Well, they not always are. You know, they're humans, but they try to communicate what they're doing much more clearly for just the reasons that we've seen here. Okay. So this brings us to the Taylor rule. And the Taylor rule is sort of the baseline way that central banks have been operating for the last 20 years or so. Now, no central bank actually follows the Taylor rule, literally. But they all have some variation. You know, they don't tell us how they're deviating, but all the talk is in terms of the Taylor rule. And I want to point this out. Can I point? Not really. I sort of point. Because this is very similar to what we saw in the Fisher-Gray model. It's not exactly the same, but it's very similar, and that's not an accident. The Taylor rule came out of these sorts of models. Okay? So it's this sort of thing. And it's saying, hey, we won't do the money supply, but we'll target interest rates. And say, what interest rate should we have? And we know that if we control the money supply, we can control the interest rate. So what interest rate should we have? Okay? And this is saying the real interest rate, that is, again, this pointing thing is problematic for IT minus pi t. Oh, man. Because I'm over on this. Gotcha. Okay. There we go. Who knows why? So IT minus pi t, right? That's, we subtract the pi. So the interest rate minus inflation, that's the real interest rate. So how much do firms actually pay in real terms when they borrow? Right? That's equal to some target real interest rate, R star. And then we're going to vary the interest rate based on how far we are off from an inflation target, that's I star, and how far we are off from an output target. And the output target is just, potential output. Okay. And so when when output is high, we are going to raise the interest rate in this linear way. And when output is low, we're going to lower the interest rate to try to get investment going. Okay. When inflation is high, we are going to raise the interest rate. Again, that's cutting back on the money supply. Right? So we raise the interest rate, we're cutting back on the money supply, and that reduces inflationary pressure. Okay. This is the idea. The important thing for us is, first of all, it's hugely influential, and this is kind of the baseline where they start their discussion from in central banks these days. But also, the fact that it's talked about so much, and it's the baseline and all of that, has very much a flavor of what we were doing in monetary policy. Well, you can think of those A's as gamma, right? Gamma on the pi, gamma on the AY. These are how we're going to respond to shocks, how we're going to respond when output is too high. And we're giving people, not exactly, but pretty close, we're communicating this rule to people. And people, they observe our behavior and they try to figure out how closely we're adhering to this. And if we do this year in, year out, we get a reputation for doing this, and therefore our promises become believable. And therefore we can affect output when we want to. Right? Okay. Now, we can throw it all away anytime by reneging on our past promises and being unpredictable. And if there's not a good reason for that, people won't believe us in the future. What does this mean? So you think, for example, we're going on like this more or less okay in the early 2000s, and then the Great Recession hit and the whole world economy went into the toilet. And they say, well, we're not following the old rule, we're going to do some special stuff. And that didn't really ruin people's reputations the way you thought it would, because This is clearly for normal times. It's not for exceptional craziness. And so people say it's fine, and they didn't seem to lose a lot of credibility from that. But if on any random year output is down a little bit and you start saying, let me just increase the money supply more than I kind of implied that I would, then your future implications aren't really believable anymore, right? So it's always a fine line between this time inconsistency problem about building a reputation for being trustworthy and predictable versus what I can get out of it now if I renege on my past promises. Okay, this is a theme throughout macroeconomics. It's particularly important in central banking. And these days, central bankers are trying, not maybe to the best of their ability, but they're trying very much to be predictable and semi-transparent in the sense that they make announcements about what interest rates, what the money supply is going to be in the future, and largely, but not always, more or less keep those promises so they get a reputation. When they say interest rates are going up, people believe that and raise the interest rates. So, and again, even if the central bank, I want to emphasize this one more, even if they're not actually following a rule, right, or even if they don't communicate a rule, we will try to figure out how they're behaving. So it's not like they cannot have a rule, right? They can say they don't have a rule, and their rule might be flip a coin every Tuesday, but flipping a coin every Tuesday is a rule. So they are going to be second guessed, right? And so it seems better to be predictable so that those second guesses have some basis in reality and stability rather than those second guesses being any old random thing that could possibly happen. Okay. So how are we doing? Okay, so this is perfect. This is the end of Fisher-Gray. That's all we got. You will have another practice problem for Fisher-Gray, but because you have to be able to do it and all that. But we are going to start international economics next time. So, okay. Have a good weekend.